Hey guys, here are your 6-6 day one notes. This section is on rational, which is just a fancy word for fractional. So when you see rational, think fractions. Rational exponents. So that means your exponents are going to be fractions now. All right, so first let's use what we know about exponents before we get into the actual details of these notes. If I asked you what is 8 squared, well, remember what exponents do. Exponents tell you how many times to multiply the base by itself. So 8 squared means we have to multiply 8 by itself 2 times. So that's 8 times itself 2 times. That's 8 times 8. That's 64. Right? Nice and easy. That's what exponents do. They tell you how many times to multiply the base by itself. So if I asked you, what is 8 to the 2/3 power? Well, that should raise a question mark, because the exponent is going to tell you how many times to multiply 8 by itself. Well, how do I multiply 8 by itself a fractional number of times? Like, I had to multiply 8 by itself twice, 8 times 8. Well, 8 to the 2/3 power means times 8 by itself 2/3 of a time. That doesn't make sense. It's kind of like negative exponents didn't make sense. How do you multiply something by itself a negative number of times? So just like negative exponents weren't allowed, they had to be fixed, fractional exponents have to be fixed as well. And you kind of already know how to fix them based off of what we were doing with our third roots and our fourth roots and our fifth roots. So before we can answer this question, because we don't know really how to multiply 8 by itself 2/3 of a time, we have to review what we know about roots, right? Well, think about what you guys did last week when I asked you guys to simplify the third root of x to the 12th. We saw there is a shortcut to taking the root of an exponent. The shortcut said it's going to become x to the power divided by the root, right? So this is going to become x to the 12 divided by 3. The root. So technically, when you're taking the root of an exponent, it turned into a fractional exponent. And the fractional exponent was made up of a power divided by a root. And then that became x to the 4th. So technically, when you are dealing with fractional exponents, they're going to turn into a root and a power, because that's what the fractional exponent is made up of. It's made up of a power divided by a root. Look here, if I asked you guys, what is the square root of x to the 20th, right? Well, the shortcut was to rewrite this as x to the 20 power divided by the root 2, and it became x to the 10th. But guys, these are equivalent statements. So when you have x to a fractional exponent, it can be turned into a root and a power. So that's exactly how we're going to deal with fractional exponents. We're going to turn them back into radicals that have a root and a power. So look here, if I asked you what's the 4th root of x to the 8th? Well, again, last week we saw we would turn this into x to the power 8 divided by the root 4, and it became x squared. But it's the same thing. These are equivalent. So we're going to turn a fractional exponent back into a radical with a root and a power, or exponent, if you will. So therefore, the rule is going to be the nth root of x to the m, using these rules, is going to become x to the power m divided by root n, right? These are equivalent. Well, all we're going to do is take this rule and use it backwards. If we have x to the m over n, if we have a fractional exponent, well, then we're going to turn it into its radical equivalent. We're going to take x, throw them under a radical, and we're going to put it to the nth root to the power of m. Now, a lot of times they'll give the power of m directly to x, but it's also on the outside of that exponent as well. But this is another way to write it, the nth root of x to the m. So that is how we're going to deal with fractional exponents. We're going to turn them back into a radical with a root and a power. And the way I remember it is the top number stays up high to be the power. The bottom number, the number underneath, always becomes your root because where are roots found? Under the ground. So the number underneath always becomes your root, and the number on top always stays up high to be your exponent. But that's how we're going to deal with fractional exponents. They're going to turn into a radical with a power and a root. All right, so now if I go back to, all right, well, what is 8 to the 2/3? Well, you're going to take 8 and we're going to turn them into a radical. We're going to take 8, put them under a radical, and we're going to give it a root of 3 and a power of 2. So there's two ways you can think of it. I tend to leave my exponent on the outside. I like to do my root first. So the third root of 8, I made up a little cheat sheet for you guys. I'm going to go to my third powers. The third root of 8 is 2. And then you still have your power to do. 2 squared is 4. So 8 to the 2/3 power, you never really end up multiplying 8 by itself 2/3 of a time because that would be impassable. You turn it into 8 to a root of 3 raised to a power of 2. Now it doesn't matter if you do the root or the power first. I like to do the root first, make it smaller, and then do the exponent last. But guys, if you wanted to think of this as the third root of 8 squared and literally give the square to 8 first, then that would become the third root of 8 squared is 64. And now you have to take the third root of 64. And if you go to your third root powers, 64, when you third root him, it's 4. So that'll get you an answer of 4 as well. So it doesn't matter whether you do the root or the power first, you'll get the same answer. Again, I like to do root first, make it smaller, and then do my exponent or power second, but it's your call. All right, so that's what's going to happen when we have fractional exponents. They're going to turn into radicals that have a root and a power. All right, let's practice it. So pay attention to the directions. This time, they want you to rewrite each problem in radical form. So it needs to be written as a radical. All right, so it says x to the 3/4. Clearly right now it's written as a rational fractional exponent. We need to turn this into a radical. So take whoever the exponent is on, in this case is x, throw them under a radical. All right, now we have to turn 3 and 4 into a root and a power. Remember, it's always power over root. So it's going to be the 4th root of x to the, now some math books will throw 3 on the outside of the radical. Some books will even go as far to use parentheses around the radical and leave the exponent on the outside. I'm not too technical, but Delta Math, where you do your homework, they're going to want you to rewrite it since you can't take the 4th root of x. We don't know who x is. They're going to ask you to give the power to x, and they're going to rewrite it as the 4th root of x to the 3rd. All of them are right, but this is how Delta Math will write it. They'll do the 4th root, and then they'll tuck the exponent right on the variable underneath that radical. All right, let's try it again. So what if they asked you to rewrite x to the 5/2 in radical form, right? We'll take whoever the exponent is on, in this case it's x, and throw them under a radical. And then you're going to split this up into a power and a root. It's going to be a root of 2 and a power of 5, right? Well, our book is going to write this, or Delta Math. We don't have to write the second root because that's assumed to be the square root, so that'll just be the square root, and they're going to give the power of 5 to x. So it'll look like the square root of x to the 5th, okay? All right, look here. What if they asked you to rewrite y to the 1/7 power in radical form? Well, take who the exponent is on and throw them under a radical. So put y under a radical, right? Now we're going to split his fraction up into a power over a root. So 7 becomes the root and the power is 1. Well, guys, do we write assumed powers of 1? No. So that would really just be the 7th root of y is how you would write that answer, okay? All right, look at part D. D is like a double whammy. You're not supposed to have fractional exponents, right? And you're also not supposed to have negative exponents. So think about how we fix negative exponents. We flip it, right? If it's on top and negative, we move it to the bottom. If it's on bottom and negative, we move it to the top. So technically right now, the first thing you should do is make it not negative. So right now it's assumed to be on the top. This is all over 1. We're going to move it to the bottom and make it z to the positive 4/5 power. And now our numerator is 1. Now we'll convert him to his radical form. So it's going to be 1 over, the exponent is on z, so put z under a radical, and it'll break up into the 5th root of z to the, put a power of 4 on it, but like I said, our book is going to tuck the power underneath that radical and put it directly on z. Perfect, done. All right, look at the last one. X to the 1/2 power. You have to rewrite that as a radical, right? So take who the exponent is on, it's x, put them under a radical. And then you're going to split the fraction up into a power over a root. So the root is 2 and the power is 1. Well, guys, do we have to write that that's a root of 2? No, that's just assumed to be the square root. And then do I have to write powers of 1? No. So technically, this is just the square root of x. When you raise something to the 1/2 power, you are literally square rooting it, okay? All right. How about... All right, now these ones. Now the ones we were just doing, they all had a base of x or y or z. We didn't know who the base was. Now these ones are going to have a number base and you're going to try and simplify them. So let's say you were asked, what is 16 to the 3/2 power, right? Okay, well I can't take 16 and multiply it by itself a fractional number of times. So in order to simplify this, I have to turn this into a radical. So take who 3/2 is on, it's 16, put it under a radical. And then we're going to take the power over root. We're going to take the 2nd square root of it and we're going to raise it to the 3rd power. So again, you can do root first and then power, or you can do power first and then the root. 16 to the 3rd is going to be a pretty big number. I like to take the root first if I can. So guys, what's the square root of 16? It's 4. Now you're going to raise it to a power of 3. So now what's 4 to the 3rd power? Well, 4 to the 3rd power is 64. Or you could use your calculator, whichever one. And that's your final answer. So 16 to the 3/2 is 64. Now again, your calculator can check this for you. If you take the number 16, right, and you raise it, I like to use parentheses, sorry, parentheses 16, and you raise it to a, I'm going to keep my fraction together, 3/2 power, 3 divided by 2, and hit enter, it's 64. Because the calculator is programmed to turn 3/2 into this. The calculator automatically turns it into this type of problem. Okay? All right, look here. What if you were asked to simplify 25 to the 1/2 power? Well, take who the exponent is on, 25, put them under a radical, and then we're going to turn this into a power and a root. It'll be the 2nd root and the 1st power. Well, guys, what's the square root of 25? It's 5. 5 to the 1st power is 5. So again, when you raise 25 to the 1/2 power, you're just square rooting it. And what's the square root of 25? 5. Okay, look here. What is -8 to the 4/3 power? Now again, negative exponents are not okay. A negative base is workable with certain types of root, right? We don't want to take the square root of a negative number, we get I, but an odd root is okay. So take whoever the exponent is on, in this case it's -8, throw it all under a radical. And if you want to leave it in parentheses, go ahead. And then you're going to turn this into a power and a root. It'll be the 3rd root raised to the 4th power. Well, what's the 3rd root of -8? What times itself 3 times gets you -8? Well, if you go to your list, the 3rd root of 8 is 2. So the 3rd root of -8 is -2. So that's going to be -2, and then you have to raise it to the 4th power. So what's -2 times itself 4 times? Well, again, if you go here, 2 to the 4th is 16. So negative 2 to the 4th, negative 2 times negative 2 times negative 2 times negative 2 is also 16. Okay? And again, I'll just show you on your calculator. If you raise negative 2, right, put it in parentheses, raise it to a power of 4 and hit enter, it's positive 16, right? You can even check this. The negative 8, right, negative 8 in parentheses, raised to a power of, I like to put it in parentheses, 4 divided by 3. Negative 8 to the 4/3 power, hit enter, it's going to say 16. Oh, wait. What did I do? Negative, maybe I typed something wrong. Negative 8 to the 4, for parentheses, 4 divided by 3. Hit enter. What am I typing in wrong? Give me 1 second. Negative 8 to the 4 divided by 3. Hold on, I got negative 8 to the 4. Oh. I'll come back to that. I don't know why my calculator is being weird. I feel like I have a setting wrong. But either way, we can do it like this. All right, now look at this one. 81 to the 3/4 power, right? So take who the exponent is on, 81, throw it under a radical, and we're going to split this up into a power over a root. So it'll be a root of 4 raised to a power of 3. So what's the 4th root of 81? Again, you can use my list I'm going to send you. Go to your 4th powers, find 81. The 4th root of 81 is 3. And then 3 to the 3rd power is 27. And you could either go to your list, 3 to the 3rd is 27, or you can use your calculator. Okay? All right. Look at this one. 32 to the negative 2/5. First things first, let's fix the negative exponent. Let's rewrite this as 1 over 32 to the positive 2/5 power. Let's make the exponent not negative. Now let's rewrite this in his radical form. So it'll be 1 over, take 32, who the exponent is on, throw them under a radical, and we're going to split this as a power over root. So a root of 5 to a power of 2. So it'll be 1 over, what's the 5th root of 32? Well, go to your 5th roots. 32, the 5th root of 32 is 2. So then 2 squared is 1 over 4. And 1/4 is your answer, okay? All right, last one, last set. Now, they're going to want you to go back. Oh, wait, I have one more example here. 1 to the 7/6, right? Take who the exponent is on, throw them under a radical, and then turn this power over root into a root of 6 to a power of 7. Well, what's the 6th root of 1? 1. And then what's 1 to the 7th power? 1. So 1 to any power, whether it's whole or fraction, is still 1. Okay, now the last thing they want you to do is take something that's written as a radical and put it back in, they're going to say rational, which is just a fancy word for fraction, form. So now we're going to take these radicals and rewrite them as fractional exponents. Okay, so here we go. So now, books write things in different ways. I'm pretty sure this is what Delta Math is going to look like. They want you to take the 3rd root of x squared and rewrite it as a fractional exponent. So it's going to be a base of x to a, remember, it's always power over root. So it'll be clearly x has a power of 2, nothing on the outside here, and a root of 3. So this would be x to the 2/3 power. And you're done. You have rewritten it as a rational fractional exponent. All right, now here, sometimes they'll leave the power on the outside, like I said. So it's the 3rd root of x and then squared. So again, it's still going to be take whoever is under the radical, in this case, x. All right, his power is outside now, so he still has a power of 2 over a root of 3. So either way they write it, you still get the same answer, okay? I just wanted to show you just in case you see that later. All right, look here. What if they had the 7th root of y to the 5th? You have to rewrite it back as a rational fractional exponent. Well, who's under the radical? Y to the 5th, take him out, right? He has a power of 5 over a root of 7. So it's y to the 5/7, okay? All right, look here. What if you had to rewrite the 8th root of 90? Well, who is his power assumed to be? It's assumed to be 1. So then take 90 out, and then it'll be raised to the power over root 1 over 8. 1/8 power. 90 to the 1/8 power. Okay, now this is crucial. You got to use parentheses if there's a negative because you want to make sure that you're putting the exponent back on everything that was under that radical. So who's under this radical? -20, right? So I want to make sure that the fractional exponents goes back on all of this. So take -20 out and make sure you put them in parentheses. Otherwise, if you don't, you're only putting the exponent on 20, not the negative sign, and they were both under the radical. So to make sure they both get the exponent, make sure you use parentheses. And then it will be to a what power? Power over root 4 over 7. So -20 to the 4/7 power. All right, look at this example. This one says rewrite as a rational exponent, right? The 3rd root of 11 to the 4th. So who's under the radical? 11 to the 4th power over a root of 3. 11 to the 4/3 power. All right, look here. What about this one? Sorry, I scribbled there. Obviously, what root is this if there's nothing written there? That's the square root of 5 to the 3rd. There is a 2 assumed to be there. So this is going to be, take out the 5. He already has a power of 3, and it's over a root of 2. Sometimes students will put a 1 there, but remember, that's the square root symbol. There is no first root. Your denominator should not be 1. Okay? All right, look at this one. The 3rd root of -27 to the 5th power. Well, look how -27 is all under the radical, right? So we want to keep it all together to make sure they all get the exponent. So use parentheses. Put -27 in parentheses to keep it all together. And now it'll be to a power over root 5 over 3. Okay? Again, without the parentheses, you are wrong. Without the parentheses, the negative sign would never have been put under the radical. And it's clearly under the radical, so you want to make sure the exponent is on him too. All right, look at this one. Guys, think about how you would say this. This is the what root of 9? This is the square root of 9. So the root is 2, and the power is assumed to be 1. So take 9 out, and we're going to raise it to the power over root 1/2 power. Okay? All right, and then last, this one's kind of tricky. Look here. You can see that there's a power of 3, but the problem is this power of 3 on y, x, and 7, or just the y? He's only on the y. So this whole problem has an assumed power of 1. So take whoever is underneath that radical, and we want all of it, so they all have to get the exponent. So use parentheses, 7x y to the 3rd, and then we're going to raise it to a power over root 1/5 power. Okay? All right, your homework should be pretty simple and basic. It should just use variables. But if you have any questions, please feel free to text me or reach out to me, and I'll be more than happy to help you. And I'm going to send you a picture of this cheat sheet that has all your square roots and 4th roots and 5th roots on it in case it helps you to get to the answer quicker instead of having to type things into your calculator. All right? All right, good luck. Let me know if you need help.